My last problem is an application of an ordinary differential equation of first order. My problem is just only it is only related to the problem in page 964, number 103. So my problem is that what if the initial concentrations in the two compartments in the previous number is XO is equal to 0 and YO is 0.10. And if in 20 minutes, this becomes 0.2 and 0.08, and what will be the time if the compartments becomes 0.04 and 0.06. Now, as we can see in this given condition, x plus y is equal to XO plus YO. This is just, if we're going to derive both sides, this is just dx in terms of t. In terms of change of time, this becomes dx over dt plus dy over dt equals 0. And we can conclude that in every y compartment, change in y compartment, we can get the negative dx over dt, which is just this, the negative of this. Now, this equation also is just y equal to xo plus yo negative x. If we're going to multiply this by 2, 2y is equal to 2xo plus yo minus 2x. Now, getting negative 2x, in order for us to substitute this equation to this given term here. So now we can get negative 2x is equal to 2y minus 2xo minus 2yo. So dy over dt is just equal to the negative of dx over dt is equal to negative KAV over V times XO plus YO plus 2y minus 2XO minus 2YO, which is just equal also to negative KA over V times the quantity of 2y minus XO plus minus YO. So, therefore, dy over dt is just negative KAV 2y minus XO minus YO. We're going to be solving this equation for us to be able to substitute this given condition. Now, dy over dt equals negative Ka over V 2y minus XO minus YO. Multiplying both sides by dt and dividing also by 2y, multiplying this by dt over 2y minus XO minus YO, this becomes dy over 2y minus XO minus YO equivalent to negative Ka over V dt. Integrating both sides, we cannot easily integrate this equation. So we're going to change the variable. So we'll let u be equal to 2y minus xo minus yo. So du will be equal to 2 dy, and dy will just be equal to du over 2. So therefore, we can now have 1/2 the integral of du over u equal to negative Ka over V t plus c. Now, integrating this side, you can have 1/2 ln of u negative ka over v t plus c. Ln 1/2 ln u is just equal to the ln square root of u. Copying this side. We're going to be raising this terms, each terms to e for us to remove the ln. So e to the ln of square root of u is just equal to e negative ka t over v times c. So square root of u is just equal to ce negative k a t v. And therefore, squaring both sides, you can get our u ce to the negative 2ka t over v. Now, remember that our u is just equal to 2y minus xo minus yo. So therefore, 2y minus xo minus yo is equal to c e to the negative 2ka t over v, or simply we can get our y as y equal to ce negative 2k at over v plus xo plus yo all over 2. So this is now our equation that we're gonna be using for the answer in this condition. Now we're going to we will go back to the condition in initial concentration at time t is equal to 0, x sub o is equal to 0, and y sub o is equal to 0.10. Now we're going to substitute this to the equation. You can have 0.10. By the way, at time t is equal to 0, y is just equal to y sub o. Now, going back, y at 0.10 is equal to c e to the negative 2k a times 0, because t is equal to 0, plus 0 plus 0.10 over 2. And by your calculation, we can get that c is just equal to 0.10. We now have our c, so therefore we can conclude that we already have our c and we also have our xo and yo. So therefore, y is just equal to 0.10 e to the negative 2k at over v plus 0 plus 0.10 all over 2, which is just equal to 0.10 e to the negative 2k at over v plus 0.10 all over 2. This is now our new equation. Now, we already answered this condition. We will go back to the next, which is in 20 minutes, the compartments will become 0.02 and 0.08. Now, by substituting this, y is 0.08 is equal to 0.10 e to the negative 2 ka times 20 over v plus 0.10 all over 2. In this equation, in this problem, we're going to be solving for k. And now, solving for k, 0.16 is equal to 0.10 e to the negative 40 ka over v plus 0.10. 0.06 transposing 0.10 to the left side, we could get 0.06 is equal to to 0.10 e to the negative 40 Ka over V. Dividing both sides by 0.10, can have 0.6 equal to e to the negative 40 Ka over V. Now, in order to remove the e, we're going to ln both sides. So therefore, we can have ln of 0.6 equal to ln of e negative 40 Ka over V. So therefore, ln of 0.6 equal to negative 40 Ka over V. And in this equation, we can conclude that K is just equal to 0.013 V over A. Now, substituting our K to our equation, which is this one, we can have Y equal to 0.10 e to the negative 2, 0.013 V over A times AT all over V plus 0.10 all over 2, which is just equal to Y is equal to 0.10 e to the negative 0.026 t plus 0.10 all over 2. Now, we already answered this condition. Now, the last equation, what will be the time if our compartments will be 0.04 and 0.06? We're going to substitute those given in this equation. So this now becomes 0.06 is equal to 0.010 e to the negative 0.026 t plus 0.10 all over 2. Multiplying both sides by 2, this now becomes 0.12 equal to 0.10 e to the negative 0.026 t plus 0.10. Transposing 0.10 to the left side, this now becomes 0.02 equal to 0.10 e to the negative 0.026 t. Now, dividing both sides by 0.10, you can have 0.2 equal to e negative 0.026. As what I've stated before, we're going to ln both sides for us to remove the e. So this now becomes ln of 0.2 is now equal to ln e to the negative 0.026 t. Now, this now becomes ln of 0.2 is equal to negative 0.026 t. And we can now conclude that RT will be equal to 61.9 minutes. We can now conclude that in 61.9 minutes, our compartments will be 0.04 and 0.06. That will be all. Thank you.